Okay, so not all the dates are right yet. I've only put, it carried over a lot of dates from, I guess, last year. So only the first one is right. And that is where that attendance quiz is. Usually they stay open for 15 minutes or so. That's where the syllabus is too. That's what I wanted to find. Let's see. This will kind of go over the idea of what we'll do in here. It's called, the course is called Additive Manufacturing, which is a much broader category than what we'll look at. We'll look at kind of the broadness of it, but we'll focus on one specific part of it with the FDM style printers, the kind that's up here. You'll have, most of what your grade is will come from actually printing things. There's two assignments where it's not a printed thing, but everything else is 2 assignments. And there's a quiz in the middle. Like an online multiple choice quiz that's mostly about content type, what temperatures are good for certain filaments and that sort of thing. And then at the end, there is either a second quiz. You can either take the second quiz, or you can just print 3 more things out of the option of stuff to do, and that can count as the last quiz. You do need to have access to some kind of printer. You don't have to bring it to class. I'm going to bring mine. I'll bring this one, or actually I'll leave this one here. I'm not going to tote it back and forth, but you can bring them to class if you want to. There's cabinets over here that you can store them in for some amount of time, although a lot of them have locks on them, so I guess you can't use that. We'll use that very first one. You don't need to bring them. So unless you have a problem, like you've got something that we need to look at and try and fix, then you don't need to bring them to class. Most of the time, anything that you print is going to take, a minimum of 20 minutes and way on up from there. So most of the time, having you print something in class isn't going to be a really viable option. But there's a couple of days. We'll do one day right before the Christmas break that is bring your printer to class if it has problems day, so that we can make sure it's printing before you leave for wherever you go for Christmas break. But other than that, and even then you don't have to bring it, it's just an option. I'll bring this one or keep this one here, but you do need to have one because most of the assignments, like 80% of the assignments, are that you printed something. So you have to either have someone who's going to let you use their printer all the time, or have one of your own. This one I have, the little Tarantula Pro, is a decent size one. It's not the smallest one you can get. It's certainly not the biggest one you can get, and it's not terribly expensive. There are plenty of these kits that are in the textbook price, the expensive engineering textbook price range. So you can certainly find one out there that will work fine. Actually, this one works pretty well. I've only printed with it once, though, so we'll see how it holds up. So I sent an email earlier before the Thanksgiving break of some popular kits that you might go in and look at. I assume everybody's kind of found one. If you haven't, then you've got a little while to do that. The way the assignment works are most of them don't have due dates other than the end of the quarter, and we'll look at those in a minute. But there's a couple that you do need to do on a certain schedule, just because if you don't do those up front, then they don't make as much sense at the end because they're more on the tuning side of stuff. Here's a little list of stuff that you might also want. If you're this number one, the painter's tape, a lot of printers nowadays come with much better build surfaces that are better at sticking your print down to it than they used to. So it used to be that almost always you had to put something on the surface to get your plastic to stick to it. And so that's what the painter's tape is. If you're having trouble with stuff sticking to your bed, one way is just that blue painter's tape. You just stick it on there and print on top of that. And that, not as big a deal as it used to. Palette knife, I didn't bring one. But just some way, a lot of printers will come with something to scrape the print off of there. But once you do get it to stick, whatever you print gets stuck on there. A lot of times it's stuck really well on there, and you have to scrape it off somehow. And a palette knife, like for painting, is usually pretty good at getting under the print and peeling it up. These do get really hot. So the little printing nozzle, the hot end here, you'll print at temperatures around and above 200 degrees Celsius, so they do get really hot. And some of these printers are very cheaply made, and so some parts are as cheap as possible that they could source. And you did build it yourself, so you probably want to have some kind of fire extinguisher or something just in case. I've never actually had one have any fire troubles, but and one of the students last year did have one get, there's a little connector on the back on some of the printers that it kind of melted. And so it would have been a problem, but it just melted and you shut it down. So just be aware that they do get really hot. And so there is the potential that they will have problems. It is a good idea to every now and then go through and make sure you don't have loose connections on things, particularly if you have one of the kits where you have to connect wires to the power supply or wires to the board with a screw terminal. You have to screw it down. Those are a lot of times the ones where that comes loose over time or whatever. And when it gets loose, then it's still kind of making connection, but not as good as it was before. And the resistance goes really high on that connection. And that's when you have to push more current through it and it gets hot. Most, including this one, I don't think this one came with one. You normally get filament. I didn't bring a roll of filament. I brought a tiny roll of filament that's not going to demonstrate purpose, but they come in like spools, but normally they're like a kilogram, and so they're really big. And a lot of printers that you get at the very lowest end of the price range don't come with something to put this on, and that's usually a problem. Like with this little amount, it won't really tangle up, but if you try to put a kilogram spool of filament and pull from that, it's going to get tangled up and it's going to jam, and it's going to knot up, and it's not going to print well or at all. So you need to make sure your printer buy some way to hold these spools of filament somewhere so that they can rotate and spin around and feed filament into your printer. And there's lots of other little things you can add along the way or whatever, and you have to have some kind of filament. Yours will probably come with something like this, depending on what you get. Some printers come with like a full roll of filament. Most of them come with a little tiny sample roll that you can print a few things with. I would say that the best thing, unless you already have printers and you already know what you're doing, then if the best, safest thing to start out with is just called PLA. So it's polylactic acid. It's kind of derived from corn byproducts. And it doesn't smell bad when you print it. It doesn't print as hot, so you can lower your temperature a little bit compared to some of the other filaments. And it's relatively easy to print. It doesn't require super special like enclosures to keep the heat in and all that kind of stuff. So it's a good filament to start with. And you can get a whole kilogram of this stuff, which if that's the only thing you printed with, it would last the whole quarter. For $20 off of Amazon. Or you go in town. The only place you can get it in town is Alvar and Herrick's that I know of. I don't think you can get it anywhere else. I've never seen it anywhere else anyway. But they do have some small selection of printer supplies and some of the hardware for printers too. They have a little bit, but they do have PL. I think they have maybe Matter Hackers or Hatchbox. I think it might be Hatchbox that they have. Anyway. Around $20 a kilogram, and you'll need at least one of those. And at that one roll, it'll be the same color. Well, actually, there's some multicolor rolls that kind of change from one color to another, but it would last the whole quarter if you wanted to. We'll meet here. We'll start at 8. It says it's 8 to 9:50. Usually, the way the classes work is we'll talk about something for a while, and then the last part of the class, however long that is, the last half or whatever is left, is just like troubleshooting things, or you're turning in assignments, or you're showing me a print that you don't know why it's doing a certain thing or whatever like that. So the second half of the class is normally more troubleshooting and not scripted type stuff. First half is usually whatever new thing we're talking about that day. And that's generally true for all of the classes. I don't think we ever spend an entire 2 hours talking about any particular thing. It's a regular 10-point scale. There are 10 things that you have to do. And so 5 of them are kind of set as here are the things, and they're described later. And then there's 2 quizzes, or well, one quiz for sure, the one in the middle, the midterm, somewhere in the middle of January. And then the quiz 2 is a similar type of quiz with different questions, or you can just print more things. And so these option 1, 2, 3, and it could be 4, 5, and 6 if you did number 10 there, the quiz 2 as 3 prints, you could do that too. So here are the different things. The perfect print, there's this little file. Let's see. I think I put it on Moodle. Yeah, this one that says 3D Benchy. It's a little boat, and it's been around for a while. And it's, I don't know, it takes 45 minutes to an hour to print one or something like that. And what it does is, it's the one that's called the perfect print. The first idea is just to get it to print. So just get the thing to print, and then you spend a lot of time tuning to fix little parts of it that didn't print as well the first time. So your printer, actually all printers that you're going to get for this class don't have any kind of sensors other than a limit switch somehow that they know where the edge of the printer is, and that's about it, and a thermistor, well, a thermocouple, so that they know what temperature the hot end is. That's about all they know. They assume everything else. So they assume that if they turn this motor, then this much filament came out and all that. So there's all the tuning that you have to do. And sometimes that tuning exists from one roll of filament to the next roll of filament. You might have to change some of those settings. And so this perfect print is kind of your getting used to tuning every time type of thing, or tuning your printer to make sure that it's extruding the right amount of filament that it thinks it's extruding, that kind of stuff. So that one, you actually turn it in as many times as you want. So you turn it in, you actually turn in the little boat. It's I don't know, 1.5 inches long or so, and 1.5 inches tall, something like that. You turn it in, and I grade it and give it back to you. And if you're satisfied, it came out really good, and you get a decent grade on it, then you don't ever turn it in again. If you turn in half a boat just because that's all it printed, then I grade it, and you get a half a grade or whatever, and you're like, well, I will print it again, and you turn it in again. So whichever one you get the highest grade on that one, that's the one that actually counts in the course grade. The next ones are a temperature tower and a tolerance test. The temperature tower is you can set your printer to print at any temperature between like 180 degrees Celsius to most of yours will probably print somewhere close to 240 degrees Celsius. So there's this big range of temperatures that you can print at, and every filament is going to have a different temperature. Like this stuff says it prints best at 200 to 210 degrees Celsius. So I would start there, but another filament I might grab might print better at 235 degrees Celsius. So the temperature tower is a way to, when you get a new roll of filament, you print this, and what it does is you have to make it do this. It doesn't just do it on its own, but it changes the temperature from, it starts at 220 degrees and drops 5 degrees every 10 layers or so, and prints a new feature, and you evaluate which ones look the best. All of this is really overview right now. We're not actually learning right now, so don't worry if none of it makes sense. It's just the idea right now. The tolerance test it's basically a bunch of concentric circles that are different gaps between the inner part and the outer part, and it helps you tune and see where your printer is able, what gap is it able to actually produce without fusing the parts together. There is a SolidWorks assignment. Most people don't like this one, but it's actually kind of important because the key part of, there's a lot of key parts, but maybe the key part of preventing most troubles with your printer is understanding how the hot end works. And so this is actually building a model of your hot end. There's usually like 4 or 5 pieces in one. Putting it in SolidWorks, doing a thermal analysis, and seeing how they actually work. And so that's one of the things that you just have to do. That's not a print. Maker coin, this is kind of well, I put a link to a thing you can, well, I think that's maybe a YouTube video. This is kind of, you create your brand, I guess, if you want to call it that, and you print the thing out. So this is more of you created it and you print it type thing. These printers do run on G-code or a form of G-code, so like a CNC mill or anything else that is computer controlled. They have even some of the same commands. They have some special commands that are specific to printing, but you're going to write a simple, it doesn't have to be complicated, but a simple code that you would load. Most of these run off of little SD card. Sometimes you can plug them into a USB cable. Normally you don't want to like leave your computer connected to it just because it might print for 12 hours or whatever, and you don't want to have your computer connected the whole time. Most of them come with a little SD card. You can write, just open up Notepad and write G-code on there and have your printer run. So that one will be very simple. Probably just make it print a couple of layers of a rectangle or something like that. Something very simple. Oh, speaking of these SD cards, so a lot of your printers do run off of either a regular or a micro SD card. The one that ships with most of the really cheap printers, and the $150s to $200 printers are the cheaper ones. A lot of times those SD cards are going to fail on you at some point, so I would just not even bother using it. A lot of these, like this one says, actually this one might be one that I bought. Nope, this is one that it came, Elite Pro, not even branded as any like Kingston or anything. Usually what these are ones that have been repackaged. So there might be actually a micro SD in here inside this thing, and it's some off-brand, and it's been repackaged. This says 512 megabytes. I actually might believe that one because it's kind of low. Some of them will say like, several gigabytes, but you open it up and what's in there is actually not that. It's just been tricked to think it's that. And you'll put a file, your computer will think it puts a file onto the SD card because it thinks there's a couple of gigabytes of space on it, and it's actually not, and the file is not all there. So it's a few lines of it and then it ends. And so if you ever are printing off of that generic SD card and it's printing fine and then it just stops printing, that's probably what's going on, is that that SD card is much smaller than it pretends to be. So I would just actually get a real SD card. You can, like I said, you can plug them in USB. The problem with that is that then you have to stay connected to it. And there are other things you can set up that to not even have to do that, but we'll talk about those later. Most of you, and including me, are just going to print off the SD card. So make sure it's a decent SD card because it is annoying, and it only happens on the really long prints because they're the larger files. So if you're a couple of hours into a print and then it just stops because there's no more data on the SD card, that's annoying. And then there's all these. So I put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, like 15 options on here. But if there's something that you want to do that I didn't really put in here, then just tell me what it is and I'll add it to the list if it makes sense as far as something that you wanted to try. There's a lot of variety of stuff on here for the optional prints, and you don't have to do all. You can do all of them. You have to do 3. So you pick 3 of them, and then you can do 6 and still get credit for the second quiz. So the first 3 plus the other 3. But if there's something that you really wanted to try out that I didn't put on here, it doesn't really fall into one of these, then just tell me, and I probably will be okay with, okay, that's fine, we'll add it to the list. And that's how some of these came on here, is like from last year, people wanted to do a certain thing, it wasn't on the list, and we added it to the list. A lot of them have links to a website or a YouTube video to kind of describe what the thing is going to look like. If they go to a particular file, like a STL file is the file you send to the slicer, to your computer, to send to your printer. Don't think that you have to use that particular file, except for if you wanted to do this one called Lend a Hand. It actually is that you have to print their parts because it's a organization. But all the others, they just give you an example of one to use. So you don't have to use the actual one that these links go to, except for that Lend a Hand if that's the one you want to do. 2 quizzes. Inappropriate assistance for homework. In this case, the homework is printing stuff. So the only real way that you could be inappropriate on this is literally having someone else pay or just print it for you. So as long as you print the thing, I don't mind how many people help you get it printing. So as long as it's printing, that's fine. Just don't have someone else print it for you. Don't go to Shapeways or somewhere and like order a print. That would be kind of silly. But other than that, I actually kind of expect that you will have to help each other a lot. So that's fine. Quiz and exams, well, there's 2 quizzes. Those you are on your own. They're multiple choice, and they shouldn't be a big deal. Projects, well, most everything is a project, so that's fine. There's really nothing. I guess the quiz, it is timed, although it's plenty of time. But if you need time and a half on that quiz, then let me know. Everything else is just to turn it in when you get it done. Honor code. Some of these, if you don't turn the actual thing in, if you just upload a picture of it, then take a 10-second or 5-second video of it actually printing on your printer, just so I know it was you that printed it. But if you bring the thing to me, then that's fine. Some of them, you just show a picture or the actual thing on the printer. Most of them you actually bring, so that is proof enough. So like I said, most of these things you could do now or the last week of class, and you'd still be fine. The only thing with putting it off to the end is if you do run into trouble, then you run out of time to fix it. So sometimes things that can happen on these printers are kind of simple to fix, that something came loose or whatever. And other times they're like you got to order a new part kind of thing. And so that takes time to get in because they're not going to be a part here on campus probably that are in town to replace whatever is broken. A lot of times the little computer inside of it will, not a lot of times, but some of the things you can't fix are that computer can short out somehow, and then you've got to source a new one of those. So don't wait to the very end to print everything because there is the chance that something goes wrong. Let's do a few safety things with this. I already talked about that they do get really hot. Some of the things that you might print with, some of the materials release, for one, some of them smell bad, so you don't want to be around them. So you don't really want this like next to your bed while you sleep printing. For one, it is printing on its own, and some printers have protections that if they notice they're getting too hot, they will shut down. Some don't. The Ender 3, for instance, I don't think it currently ships with thermal runaway protection built into it. So you have to add that if you want that. Most other printers, I think, have that. You have to check on the Ender 3. It was the one that I did remember relatively recently not having thermal runaway in this firmware for it. And it's something you can change that, but I think by default it wasn't on there. And then again, some materials, PLA is not noxious to most people. It's kind of, it doesn't smell particularly strong at all. ABS does. I wouldn't recommend dealing with ABS at all unless you have printed several other things successfully. Some of your printers, particularly some of these TiVos, sometimes they ship ABS as your sample filament. I wouldn't bother with it right now. For one thing, it does kind of smell bad in a small space, and it's harder to print in general on an open printer like this anyway, well, that's not enclosed. So I would just stick with PLA for the time being. And there's some other relatively easy to print materials also, but PLA is probably your best bet. And so you do want to have them printing in a space that is ventilated, some airflow, because there's research, well, I don't even know if you call it research. There are people who kind of every now and then check to see what kind of nanoparticles get released during this printing process. And some people measure some things and say that, yeah, there's some. Others are like, well, that's not enough to worry with. And so there's no definitive statement on if you have a single printer printing PLA, it's going to create respiratory problems. Now, if you had 50 of them running, I'm pretty sure that would be a problem. But if you have one running, it's probably not going to create any problem. But just be aware that you wouldn't want to be in like a closet with this thing printing because there are particles that are released during the printing process that you might that might be sensitive to some people. Some people might be sensitive to them, rather, I guess. Other than that, I think that covers the syllabus and everything. Are there any questions about that stuff before we do anything? Nope. Well, ask any if you think of stuff. I think what we'll do is we'll kind of go through the general idea for a little bit, and then we won't stay terribly long, but we'll talk a little bit. So I'll sit down. The course is additive manufacturing. So let's talk a little bit about just manufacturing. Not a lot, just a little bit. You actually, most of you probably have had the 321 manufacturing class, but this is going to be my version of manufacturing. So just in general, it's not going to include every possible way to manufacture something, but there are a couple of big categories that most things fall into when you're manufacturing, and why this is called additive manufacturing. So manufacturing in general, one thing that a lot of things are made, one process is injection molding. We actually have a little, it doesn't get used much at all, but we have a little injection molding machine in Bogard in the 126 lab. But this is where you take a cavity of some sort and you squirt plastic into it. And so a lot of things are made, a lot of cheap stuff like this little housing, probably, yeah, it's injection molded. So a lot of, oh, yeah, I have this. Let's see. Where's our, let's go closer. So whenever you see, oh, can y'all see it? Yeah, you can kind of see that one. Like these little circles on the back side of something. Yeah, you can see that. It's kind of on top of that thing. These, not the round, not the hole, but these little circles and like that one. Those are ejector pin marks where this thing was in a mold, you know, a 2-part mold. They squirted plastic in, and then these pins, and there's 6 of them on here, I think. No, there's 8 of them on here. They push the part out, and then the mold clamps back together, and they do it over and over 1,000 times an hour or whatever. That means that this thing was injection molded. That's one sign that this was injection molded, is that it's got these little ejector pin marks on it where the part was ejected from the mold it was in. And so a lot of things, a lot of particularly the cheaper plastic stuff was made with injection molding. So a lot of stuff injection molded. Let's see, what else did I have on here? iPad keeps going off. Oh, well, so we're talking about additive manufacturing. So there is a subtractive manufacturing. So milling and lathe operations and things like that, where you start with a block of stuff and you cut off all the stuff you don't want. That's subtractive manufacturing, and there's a lot of different ways to do that. Forming. So the really, really cheap plastic stuff, so the stuff that like a blister pack that some SD card came in or whatever, that stuff's vacuum formed. So you take a sheet of plastic and heat it up and suck it down over some form, and you vacuum form it. And you can form metals, you can stamp metal and press metal and that kind of stuff. So there's forming in general. Joining, so you might weld stuff together. And casting, you actually did some casting. So you've done, if you've done 321, which I assume everybody has, you've done casting and subtractive. I guess you've done those two in that class. And certainly you've joined, you may not have welded something together before, but you've bolted something together before or screwed something together. So you've joined things. You may not have done forming or injection molding, but you at least know what they are. So those are kind of most of your traditional manufacturing processes. And then we're over here in this new thing. I say it's new. It's actually probably older than you think. The first 3D printers were around in the 80s. So there were SLA, so they had a vat of liquid resin and used a laser to cure it in selective spots. Those were around in the 80s. And people use this idea plenty, the pyramids are basically really giant versions of additive manufacturing where you stack things on top of things. And so it's not that it's very new. What's new about it is, so in the 80s, the companies that own those patents patented everything, and kind of, it was never actually manufacturing, and it's still not really manufacturing. Although there are places where it's getting closer to be manufacturing, it's still mostly prototyping or really short run type things. So making, hundreds of things maybe at the high end, whereas, manufacturing is usually thousands or tens of thousands of things. So it's not that you see these little 3D printers on an assembly line anywhere really yet, although there are some companies that have models similar to that, where you have print farms that print parts for other printers or print parts for the automotive industry. There's some housings for electrical connectors that are 3D printed. There are some industries where the geometry is just really complex. And so these traditional injection and subtractive, they're nice, but they have downsides when it comes to really complex geometry. You have to have super sophisticated machinery to make some of the really complex, like turbine blades and that kind of stuff, or voids on the inside of parts. How are you going to make that? If you're trying to drill it out, you have to drill it out and then fill it back in if you want a hole in the middle of it that doesn't go all the way through on either side. So additive manufacturing most of the time doesn't actually care about the geometry. There are some limitations, but there are even ways to get around that limitation relatively easily. And so additive manufacturing has this advantage that the geometry can be much more complex than some of these other more traditional manufacturing processes. The downside is, so it can use more complex geometry can be made. The downside is that it's slow, generally slow compared to most of these. Now, subtractive is not particularly fast either, but injection molding, you make tens of thousands of parts a day. Vacuum forming, you make even more. Joining is pretty fast. Casting is kind of slow. You have heating up metal, cooling down metal, and all that kind of stuff. So it's a slower process. Subtractive, you have to go and manually remove, or maybe computer remove every little piece you don't want. So they're kind of on the slower end. Additive is on the slower end of getting parts out the door. And generally, the parts are not isomorphic. Sometimes they are, not always. So we'll put that right there. Not always isomorphic. So particularly with this style, the printers that we're going to use in this class, they are much stronger in one direction than another direction because of the way they're made. The resins, the ones that use lasers and UV light and that sort of thing, they're generally pretty isomorphic. So they're equally strong in all directions. But some of the other processes, particularly the cheaper processes, are not. They have grain to them that makes them sort of like wood, where they're strong in one way and not another. And so we're kind of over here in this additive manufacturing arena. We're not going to get into the manufacturing side of things. We're going to although you can relatively easily open up a little Etsy store and sell something, vases or whatever. We could probably go on Etsy right now and look for vases, and there's, I don't know, 40 different ones to choose from, and it's just 3D printed vases because you can make the really complex geometry. So you can make interesting looking things that you couldn't normally make. And you can do it relatively quickly. So a vase, the size of this, I don't know, it might take you 2 hours to print, maybe something like that. It's not terrible because it's not solid. It's just a bunch of walls. And so you can make some money doing it. But most things right now are not manufactured using this. There are a couple of printers. I think the most likely one right now is called Carbon. I don't know their full name. Maybe it's Carbon 3D or something like that. But this printer is a resin-based printer that can print in a lot of different materials, and it's relatively fast. It uses a little bit different technology than the other resin-based printers to print parts at a reasonably fast rate, and the parts are pretty much, 90-something% as good as if you made them in these other ways. So there are ventures out into additive manufacturing. What I was going to say is what's new is those patents from the 80s and the 90s and even maybe into the, well, not the 2000s yet, but late 90s, they ran out. So patents are only good for 20 years in the United States. And the deal with a patent is that in order to receive a patent, you have to describe how you do the thing, whatever the thing is. So the hot end for the 3D printer, you have to describe how it all works. You get protected for 20 years that nobody else can infringe on that patent. But then after that, then it's wide open. Anybody can copy that design, and they can sell it if they want to after 20 years. They can do whatever they want. And so what happened was a group of people not really trying to sell 3D printers, but trying to, hey, this would be cool. These patents are available now. We can make these things. And they started building they didn't look a lot different, but they were wooden, laser cut wood panel. There's one in my office if you want to see what they used to look like. And they were very poor printers, but they worked. They could heat up metal, or not metal, heat up plastic, squirt it out, lay it down in a certain pattern, and then let it do that over and over again and print little objects. And so they weren't that great, and they were kind of expensive for what they were. But it opened up this whole industry. Now this little TiVo, this Chinese company, will send you this thing for $180 or whatever from China. And then there's all kinds of similar companies that are doing the same thing. So that's what's new about additive manufacturing, is that these, and I don't know that these are called FDM printers. So let's talk the general types of additive we'll call it manufacturing, even though we're not really manufacturing things right now on a large scale. There are ones that are based around some kind of liquid. So these are going to be maybe a SLA. So like these were the first printers that were commercially available, were these SLA resin printers. So you had this vat of polymer, and you shined a laser on the polymer in certain patterns, and it made prints. That technology hasn't really changed much at all, other than they've built different resins. There's much more blends of resins now, but it's still very similar to the way it used to be in even the 80s. And so these can produce really highly detailed model. I remember the first one I saw was in Memphis in 95 or so, and it was at a orthopedics company, and they had one of these just to make prototypes of stuff, and like images of bones from CT scans. They could 3D print the bone and then build some kind of orthopedic or device around it. Anyway, they had printed like this little tree, and it had all the leaves and branches and everything, and that was in the mid 90s when that was going on. And so this TiVo printer would have trouble printing something like that with that much detail, just because of the different technology. So when you want really high detail, you usually are going to one of these resin type printers. But these things really expensive. Like the good one of these now, it's like $150,000, $200,000, somewhere in that range, or more. But recently, people said, hey, resin doesn't just cure with lasers, you can also cure it with UV light. And so they took basically cell phone screens, shined UV light through them, and used the cell phone screen as a mask, so you can make the screen whatever pattern you want on there. And they have these now that you can get for $300-400 that cure with UV light. And so they're on the kind of cheap side, So this is like, I don't know, $200K or so for a good one of these. Now, there is this in between that's in the 5,000 range to 7,000 range that does use a laser to cure resin. and it's called, so this would be a printer like the Object, I think is the way. There's one in here kind of in the middle that's called the Formlabs Printer, and they have different, Form 1 and 2 and all that kind of stuff. It's kind of in the, I don't know, maybe 6,000 range. These little guys down here, maybe I'll just put $1 sign on this one. This one, a good one is like the Photon, and it's $400, I think, probably. You can probably find it for $400. And all of them are able to printing pretty high detail. So you might get layer heights in here in the 0.05 millimeter range or less. So really, you kind of, the layers start to vanish at that point. This thing, a lot of times I'm printing this one at 0.2 millimeters or 0.3 millimeters if I want to go fast. And that looks decent. But the nice thing about lasers and UV is that if I were to want to print 10 little chess pieces on the FDM, the kind of printer that's sitting up here, it would take 10 times as long as printing one piece. But if I want to print 10 copies of a thing or whatever, 10 different things, doesn't matter, on one of these SLA printers or the UV style printers, it doesn't really, it might take, on the laser ones, it might take 2 or 3% longer. On the UV style, where it exposes the whole print area, now it's a small print area, this little guy is maybe around 6 inches by 4 inches by, I don't know, 7, I don't know, I'm guessing somewhere in that range. So it's kind of a small print area, but it exposes the whole surface at once. So it doesn't matter if you have one thing on there or 20 things on there, it's going to take the same amount of time to print it, depends on how tall it is. So these are good for really high detail, and you have resins that can be flexible, you have resins that can be rigid, translucent, so you get those types of material properties there. You have another set that is based around some kind of powder, and these kind of fall into a category of a binder jet. So this is really like, in fact, the first one that I saw of these used inkjet printer cartridges. So you took an inkjet printer cartridge, and it would have, I think it had 4 or maybe 5. One of them was basically a glue, so a binder, the stuff that held the powder together, and the others were color. So you could actually print in full color. And they are able to print full color. You can basically, what you did is it had a layer of powder, and then you bound part of it together in whatever color you wanted, and you scraped a new layer on top. The machine did all this, you didn't do it. And then it built this up layer by layer, just like any of these others. And then when it was done, you dug it out of the powder and you infused it with super glue, more or less. Now there are other things you can infuse it with to make it flexible or whatever. But the idea behind these was that you kind of temporarily glued it together with this binder on a inkjet printer type cartridge, and then you finished it later. They're kind of weak. These resin parts, the carbon printer, this one here, is one of these resin printers with a little bit special technology to make it faster. But those parts are a lot of times the ones that do show up in additive manufacturing are in that resin category. The powder ones, they're just prototypes. They're not really going to be usable parts. They're kind of fragile. They're better now than they used to be, but they're kind of fragile, except the other kind of this is called SLS. So this is, SLA was selective laser apparatus. SLS is selective laser sintering. So sintering basically means melting it together. And the powder is stainless steel or titanium or something like that. And so these things they're super expensive. We don't have one of these. We actually had one of these binder jets and we gave it away just because we never did anything with it. But these SLS metal printers, they can print in metal, but the cheapest ones of these are gonna be in the 200,000 range, and they're gonna go up very quickly from there, $500,000 or more for these things. And they have really tiny build volumes usually too. There are some people trying to come up with different ways to create metal parts. Currently, the most popular but expensive is this selective laser sintering, where same idea, where you get a powder of titanium and you shine a laser on it to melt the particles together. You put a new layer on top and do it again and again. These are the ones where you need a metal part, so you need the strength of a cast part or whatever. It'll have similar strength to a cast part, but you need it in metal. You can do it this way, and it'll give the ability to create that really complex geometry. What we're doing kind of revolves around plastic, right? So we're in over here, and this is FDM, so fused deposition modeling. Now, so the patents on these early FDM style printers from Stratasys, is who owned most of them, they ran out, but their trademarks didn't, and FDM is actually one of their trademarks. So a lot of times you'll see people use FFF to mean this, and this is, let's see if I can get to write it down. Fused, I didn't write it down, but I remember it. Fused filament fabrication. So it's the same thing, but FDM is actually, I think, trademarked, and so sometimes people get in trouble for using FDM. So you'll see FFF. And these fall into, there's all sorts of plastics. You can print in nylon, you can print in PLA, or actually this is, I don't know what this is. This is, I don't know. It says print like PLA. Oh, it's biofila. I don't know what that is, but it's prints like PLA. ABS, so ABS is the material like your car bumpers are made of. You can print in PETG, so that's somewhere between PLA and ABS, but not as noxious smelling and everything as ABS is. And there's you can print filament that is the base filament that has got stuff embedded in it. So it might have copper particles in it. You can make a kind of coppery, you can kind of print metal. It's not, it's like maybe 10% metal or something, but it has some of the metal properties. You can infuse, they can be glow in the dark, all kinds of different things can be put into this plastic. These printers, I want to put them into 4 different broad categories. One that I'm going to call maybe just, I'm going to base this on Enders. They have an Ender 2, 3, and a 5, so this will be the 2 series. So these printers have an upright piece, so that can move up and that this little cantilever beam can move up and down on, so you can move this way and this way, and then on this cantilever beam is your print head, and it can move this way and this way, and then there's a little bed down here that moves back and forth. So these, like this, an example of this one would be the Ender 2. Ender 2, there's one called Cetus that's like this. I think TiVo has their version of it. These are usually kind of small, so if you don't have a lot of room, oh, the Up Mini, I think, is the other one. Maybe that's what it's called. That's a decent one of these. They're usually on the cheaper end. A lot of they can either be a kit or not. I think the Up is not. I think it's the Up. I might have to look up, make sure that's the right printer. But the Cetus and the Ender 2 are kind of a little kit you put together. And they're fine. A lot of times you don't need a big printing surface. The only, a lot of times you're printing stuff that will fit on these smallest little printers, and they're fine for that. And so these are kind of in this, what I'm calling the 2 series. Mainly they have, they've got one upright piece, a cantilever piece, and the bed that moves. And then in the 3 series, you've got like this TiVo here, where you've got 2 upright pieces. So you got a whole gantry. Maybe they're connected to the top. Most of the time they are. There might be some printers that are really cheap that aren't connected across the top. But you have this gantry, and you've got your axis across here with the hot end on it, and the axis can move up and down, and the hot end can move across, and then you've got the bed again that moves frontwards and backwards. All these where the bed moves, they have the disadvantage of the bed is relatively heavy, and if you want to print quickly, then you've got to deal with the fact that this bed has inertia and you have to move it back and forth really quickly. And so it limits how fast you can print a lot of times because of just the massiveness of the bed, having to accelerate and decelerate and change directions back and forth all the time. The print head itself is not as heavy, but it can also suffer from that. And there are things you can do with that. One thing you can do is, a printer like this one would be the TiVo Ender 3, Creality, CR10. However you spell that, CR10. Those are those type printers. Some people said, well, let's not move the bed. And so they built what we're going to call these Core XY. Ender actually calls it the Ender 5, I think. And what they did is they built a box. So you have 4 uprights, and the bed is in here, but instead of moving up and back and forth, the bed moves up and down. So the bed, when you're moving up and down, you don't have to move very quickly because you're only moving like, maybe 0.2 millimeters, 0.1 millimeter, something like that. So it's moving pretty slowly. And it's just one step at a time, more or less. And so that you don't have that inertia. And they've got the print head up here, and it moves in 4 directions. So there's little rails for it to ride on in all 4 directions, and it just kind of sits at the top. And actually the bed starts all the way at the top and lowers down layer by layer. And then there was another group, actually probably before the Core XY. So the Ultimaker is this kind of printer, probably your best version of this or example of this. There's probably other, well, the Ender 5 is also this way, I think. Some people didn't want to move the bed at all, so they have these Delta printers. And what they do is they have a bed that stays at the bottom, 3 uprights, and the print head is in the middle, and it's connected to each one of these uprights. And the way you move the print head in X and Y and Z by moving each one of these up and down. So they're really interesting to watch move around because they're very fluid, so they don't have the sudden, like I'm going one direction and I'm suddenly have to go the other direction. They don't really have that going on because as much. Obviously the parts connected to the uprights move up and down all the time. That's all that moves, is they move up and down. And their position controls the position of this print head in the middle. The print head is generally really light, so you can move it very fast. So these are your fastest printers, and they're usually tall, so that you can usually print really tall things on them. They kind of suffer, if you try to move this print head way over to the edge somewhere and print, then sometimes that creates a little bit of trouble. It's not this way, but what a lot of times these suffer from is as if this print surface was bowled, like it was a concave or convex thing that you were printing on. It's not actually that way, but the way that they move, sometimes it suffers from that. But they can print really quickly. They're really fast because you can move the print heads pretty quickly because it's really light compared to everything else, and it doesn't necessarily have to shift directions quite the same as these other style printers do. Most of you are going to have one of these guys. That's probably what you're going to deal with. The Ender 5, you might have that. It's relatively affordable. The Ultimaker is kind of expensive, $2,000 or whatever. But all the Deltas, you can get a little Delta printer. I would not get a Delta printer for this class unless that's just what you already have. Just because some of the stuff that we would like to do isn't as obvious how to do it in the Delta printer. So unless you already have that, I wouldn't get one of those for the class, although they're kind of fun to print with. You might can have one of these little Ender 2 style printers, one of these. They're not necessarily much cheaper than the 3 series printers. They might be a little bit cheaper. They're smaller though, so if you don't have a lot of space, then they're kind of nice for that. And then there's all these other things. There's some really weird stuff out there. Like there's a printer, or there was, I don't know if it still exists, but what it did is it basically took a roll of paper and it cut out every layer. Like it would cut out one layer and then it would cut out another layer, and it would put these little index holes in them, and you glued all these layers together, or I think more recently they glued them, the printer itself glued them all together, and it would be full color, everything, but your part would just be like stacks of paper glued together. There's some that print in candy, so like extrude chocolate. There's some that extrude ceramic for pottery, sugar, all kinds of different things like that. So there's some oddball printers that are very specific to what they do. We're pretty much going to stick all the stuff that we're going to talk about is going to fall into this FDM. We do have some of the resin printers, and we'll do maybe a little bit with those. They're very messy is the problem with them. So you get the part out of the liquid resin, and it's still there's some curing that has to happen. So they're kind of messy to deal with, but we do have some, and we can play with those a little bit. We don't even have the powder printers anymore, and we don't have a metal printer. And we don't have any of these paper, chocolate, ceramic printers either. We don't have any of that. So when you're looking at your printer, and let's see, yeah, I think maybe we'll try to print something. I haven't printed with this printer in a while, so we may not be successful. We'll see. You generally have like 4 pieces of it that matter, and then everything else is either an upgrade or a better version of the thing, or you added on something to make something simpler. But you got to have some surface. When you see them and they've got this foil on the bottom, a little thicker, what that generally means is this is a heated surface. PLA, you don't have to have a heated surface, heated bed to print. But other materials, you might have to have one of these heated beds. So some of your printers, like this Cetus, the one I wrote over here, that Cetus, it does not by default come, it's an optional thing with a heated bed. So if your printer does not have a heated bed, you're going to be limited on the materials you can print. But one of the materials you can print is PLA, which is the one I recommend you print anyway. So you have to have some kind of bed. Sometimes the beds that you get, like this one's a relatively thick piece of aluminum. I haven't actually tested it to see how flat it is, but they might not be flat, and that makes it a little bit difficult to print. One thing you can do is just go to Walmart and get a little mirror and put it on top. The mirror is pretty flat, or just a piece of glass. Doesn't even have to be a mirror. The mirror is nice if you have a heated bed, because the backside of the mirror is coated with silver of some kind, and so it conducts the heat better. But doesn't have to be a mirror. It can be a piece of glass if you don't have a heated bed. It can be a piece of glass if you do have a heated bed. It's fine. But that is generally flat and will kind of level out whatever unevenness. So if you're always looking at your bed and you can never, it's not flat, then you put some kind of straight edge across it and you see big dips or whatever, then that's one way you can fix that without having to spend a lot of money. You can always buy other beds and other things to put on top of it, and you can spend as much money as you want to. The other thing you can do is some printers, this one does not, but some printers come with sensors that go in and test, they poke on the bed in different intervals to map it out, and they adjust for any waviness in the bed in the software. So the software itself actually just moves up and down on those first few layers to trace the surface of the bed to make sure the print sticks to it. Most of these lower end printers don't come with that built in. You probably are looking at a $400 or $500 printer to have that already built in. The sensor itself is maybe, depends on what the one you get, but in the, I don't know, $30 range maybe. I'd have to check. But you got to have some kind of surface to print on. Normally, I shouldn't be touching this because I don't have any way to clean it. Normally, if you touch the thing, then you're going to get it oily and your prints aren't going to stick very well. I bought just like 1,000 pack of the little alcohol swabs for like if you're going to take a shot or whatever. And
wipe it off every time. Or you can get a little spray bottle of IPA, isopropyl alcohol, and just spray it off and wipe it off. Don't use like acetone or something like that. Just use IPA or the alcohol swabs or something like that. They're also IPA. And that's good enough to clean off the thing, but they're not going to damage it. Acetone can damage some other stuff, unless it's glass or whatever. So you got to have this bed. You got to have some way to control it. So there's a little computer inside here. A lot of those are actually based on, we'll look at the code that, not today, but later on, the code that's the firmware on your machine. It's just written in an Arduino language. So most of those are Arduino-based processors inside there. They're not literally an Arduino. Actually, the old ones were. You would have an Arduino Mega on top of, with some hat on top of it to have motor drivers. They run off of Arduino language though, and they just don't look like a typical Arduino. And you've got all these stepper motors. So here's one. There's one over here. One up here. So that create all your motion. So you should have 4 of them. Some of you might have more, but you have one for each axis. So there's one here to move back and forth. Oh, you shouldn't really move these around a lot. Not very quickly anyway. You can move them slowly. But the stepper motor, when you drive it basically becomes a generator. And so it sends current back into your board. And not all the boards are protected as well as others. And so if you move this bed back and forth a lot quickly, you'll send current into the board and it can sort stuff out. Same thing with any of them, like this one. So you can move them, just don't move them fast if you need to move them in position for something. So there's 4 of those at least. One to move this way, one to move this way, one to move up and down. Some of you will have 2 to move up and down. This printer only has 1 of these rails. Some will have 2 for to kind of keep this parallel versus it tilting, being controlled only by 1. And then you'll have 1 that drives the filament in. So there's 2 different styles of this extruder setup. This style uses the feeder, the part that's moving the filament. It's not part of the print head, so it's not moving around. So that's called a Bowden tube. So those little tubes, a Bowden tube, or a remote printing or something, a remote drive, something like that, where the stepper itself doesn't have to move. It moves up, it moves up, but that doesn't really affect your printing. It's the weight of these things is not on here. There are other printers that put this right here on top, and so that's called direct drive. Of these, the Ultimaker doesn't. Actually, maybe none of those have direct drive. I don't know if any of those that I listed have direct drive. The Prusa has direct drive on it. I didn't put that out there. That's a $700 or $800 printer. So the advantage of that is, like, the thing that's pushing the filament is right here where the filament is going. With this one, I have to push the filament down this tube. This one's not terribly long, but sometimes there are longer tubes, and it can create drag inside there. It can create a little bit of problems. You don't have as much control. If you want to print a flexible filament, so they actually are, there are some filaments that are rubbery and the part ends up rubbery. They're harder to print on these where the feeder is separated from the extruder, the hot end. So the advantage of putting the feeder right on top of it, the direct drive setup, is that you don't have that problem. It feeds directly into the hot end and it melts and you squirt it out. So you get a lot more control and your surface finish can be a lot better. You can print the flexible, as soft a filament as you can find with no problem. The downside is that you put extra weight on here, so a lot of times you're printing slower, or the printer has to be a lot more rigid. So you got to have those pieces, and you got to have the hot end part. So that's the key part, and that's the part that'll probably give you the most trouble. Don't be afraid to, take this when it's not printing, it's jammed up, to take this thing apart and figure out what's going on inside there. It's probably clogged up somewhere. So let's see if we can go through the process of printing something. I didn't actually go get anything to print, so we gotta find. Obviously, you can make your own. You can go to SolidWorks and make your own parts and print them out.
I'm just going to go to a I'm going to try to go to a website called Thingiverse and find something. Oh, you know what? We're going to find a calibration cube. Oh, I have to sign in to download stuff. If you don't have an account here, you have to, it's free, but you have to create one in order to download anything. Let's get a calibration cube, or cub, whichever. Try that again. Cube. All right, so these little things are just 20 millimeter cubes. So this is a lot of times this is one of the first things you print on a printer, just to make sure that it's extruding right and it's more or less printing the right size. I didn't bring anything to measure with, so we won't be able to measure if it's actually comes out 20 millimeters. Do not worry if you get calipers out and you measure this thing and it's like 19.5 by 20.4 by 18.9 or whatever. The 18.9 maybe you worry about, but don't worry if it's not exactly 20 millimeters. You're just looking for right now that it's close to 20 millimeters. Let's see, this first one looks like a lot of people downloaded that. So here, what I'm looking for is not details, I want files. Files. I'm looking for something that says STL on it. So XYZ Calibration Cube STL. If you remember back from 120 maybe, might be the last time you did this, SolidWorks or any kind of 3D modeling program will generate an STL file. It's not their native format, but they can export STL. Normally that's the file type that you want, unless there are a couple of others that you can use. And there's a newer one that's kind of starting to make its way through, but STL is probably what you're going to find, and that will work fine. So that I cannot send that STL file to the printer. What this file is basically this geometry turned into nothing but triangles. So it's it makes that same shape just out of nothing but triangles. And the printer, as far as I know, there aren't any printers that can take a STL file directly. What you have to do is you have to go and slice this file. So I have a couple of different slicers on here. I am going to use, I hope I have Cura. Yes, I have Cura. So it says Ultimaker Cura, so you think it's only good for Ultimaker printers, but it can work with almost any printer. Probably any printer, actually. So I'm going to let this thing start up. Probably should have already started it. There are different slicers. There are a lot of different ones out there. Cura is just one of the better supported free ones. Slicer is also pretty good. And the Prusa slicer that it's built on, or that slicer is built from, whichever way you want to look at it, is really good. Cura is probably your most generic one that's popular. Apparently it's really slow to load up though. It's free. You have to tell them like why you're using it, educational use or whatever, and then it's free. But yeah, most of the slicers are free, other than Simplify 3D is not free, and I don't think it's gonna. Oh, look, I can already get a new one. They do update this one pretty often. I'm not going to bother updating. So if this was the first time I did this, it wouldn't know what printer I want to set this up for. So some printers are bigger and smaller, and they use different systems of moving around. And so the very first time you do have to set up a printer. So if I were doing that, let's see. Oh, no, that's if I want to load something. I don't want to do that. That's a load a file. I think right here, you wouldn't have anything named. Maybe it starts out with Ultimaker. And they keep changing these menus where everything's at. This is the 4.3 version. Apparently you'll download the 4.4 version, which probably looks similar. You go up here and you add a printer. And they have, oh wow, that's all cluttered up. All right, so you probably aren't going to have a networked printer, so you don't need that. So you probably want to add a non-networked printer. And then they have a list of all these different printer types. There's all the Ultimakers, and then you can make anything you want in here. And then there's a lot of the different manufacturers. So ANET is one of the ones that you might have. It's one of the cheaper printers. Let's
let's see, Creality. So all your Ender stuff is probably in there. Yeah, there's, whoop, there they went. So all the Enders are in that Creality set of printers, and the CR10 and all that kind of stuff. TiVo's usually they're in here. Let's see. There's a lot of different ones. MakerBot's in here. I doubt any of you have a MakerBot. Monoprice, that's the little one, I think. The Up Mini is the one that, or I guess it's the Select Mini. Select Mini, okay. Prusa, those are good. I have a TiVo. I can probably type in and search, but I'm just looking through them. CME CNC, those, they produce some of the good Delta printers that I've seen. TiVo, all right, so the Black Widow, that's a really big one. Tarantula is the one that's here, and the Tornado is kind of the medium-sized one. So I would pick Tarantula. And so what that does is it basically goes in, I've already done it, so I don't need to add another one. It adds in the option here that I've got, actually I've got two for some reason. All right, so I put in that I want to use whichever one I want to use, and it sets the build volume. So I've got this little kind of view of what size I've got to work with, and this little outline of how tall I can make it. And your part has to fit inside that build volume. And so it'll set that. It'll set things like different extruders need different factors to extrude the right amount of filament. And it'll set all the stuff that it knows, all to kind of generic, this should work out of the box type settings. And then you go and tune it from there. We need to get our calibration cube. There it is right there. So we'll open that. And it sits in here. And, oh, I can't zoom. Okay. Let me see if this mouse will connect. Yeah, all right. So there we go. So it puts an X, a Y, and a Z on the thing. And those are the X axis. You know, this was printed in the Y direction, and Z was printed in the Z direction. And so it kind of lets you orient it, because what you're looking for, you're looking to see if the dimensions are correct, but this will help you reorient it if one of them is not correct. It'll show you where you might have a loose belt or something like that. Or if there's some features, sometimes there'll be little bumps on behind some of these letters. It'll let you know that maybe you were printing too fast in that direction, something like that. So anyway, I get the geometry. This is the STL file. And then I have to set up how do I want this to print. And so Cura, by default, has this really simplified set of settings here, where do I want fine? I don't want fine. I want draft. We'll throw that away. Now, actually, it put draft at 0.2. So this layer height, there's a whole bunch of stuff. There are pages and pages and embedded links and embedded, drop downs and all this kind of stuff that you can go through and tweak every last little detail. For now, you kind of want to look at this one, layer height. So it's the ones that they put up here at the top. The layer height, so that's how thick is each layer going to be. And the thicker you make them, then the faster, well, the fewer layers you have to print. So they'll generally print faster. And there is a limit. So most all of your printers, the nozzle, the little end in here, the hole in the hot end that the filament comes out, is 0.4 millimeters. So by default, most of yours are going to print, or they're going to squirt out filament that's 0.4 millimeters in diameter. In general, you cannot print layers that are more than 75% of that size. So 0.3 millimeters is about as thick of a layer as I can print with a 0.4 millimeter nozzle. I could probably go a little higher, but it's tough. You have to trick it into doing anything more than that. If you really want to print fast parts and you don't care about how thick the layers are, what you have to do is you change from a 0.4 millimeter nozzle to a 0.6 or 0.8 or a 1 millimeter nozzle. And then you can print thicker and thicker layers. Obviously, the thicker the layers are, the more it looks like a 3D printed part. You can see all those layer lines. You can go down to, let's see what it defaults down to. 0.06, extra fine. And it can almost disappear the layer heights, the layer lines. The problem with printing that small is that, well, one thing, it takes forever. Another thing is that your nozzle is on the same spots a lot. So they're not separated by a lot, and so it can heat up the subsurface layers and kind of distort everything. So you have to be careful printing at these really thin layers. I would not recommend starting anywhere below 0.2. I would start at 0.2, maybe 0.3 even, but 0.3. 0.2 is good. This one is talking about how solid do you want it to be. So you can print these things with just a shell or some amount of interior, all the way up to solid. 20% is probably a little higher than I want. I'm going to print this at 10%. And then there are other patterns and everything. I don't worry about that. This one is support material. So one of the things with the advantages of additive manufacturing is the complex geometry. Sometimes, though, you still need to support that geometry. Like if I want to print something, if I want to print this phone up in the middle of the air, I can't just start there. I have to have something for it to hold it up and then print on top of that. So those are supports. I don't need supports for this one. I'm going to print it straight on the surface, and there's nothing that's really overhanging. There kind of is. So if we look really close, like the top of that Y and the X, those are just hanging out in space. But what they're doing is they're going to see, actually it even shows them as red. All the red surfaces are overhangs. I don't know if I can make it rotate. There we go. So it's showing that those are unsupported. But what it's going to do is it's going to print over here, and then it's going to bridge across to over here. And that's such a tiny little gap that it'll be okay. You can bridge a couple of centimeters probably on most printers without too much trouble. And so that's certainly not going to be a problem. So I'm going to leave support off. This is bed adhesion, this last one. And so it is on. And what I've got it set to is probably a brim. So I actually don't want a brim. I want a skirt. So there are 4 generic types here. Skirt is, it's going to print basically some outlines just to purge the nozzle basically and make sure that it's printing. I usually use that to make sure it's going to work. So I usually use brim. If I think it's not going to stick very well, it doesn't have a lot of surface area. Oh, actually, I mean, I usually use skirt. And if I think it's not going to stick very well, then I'll add a brim to it. I think I've got these right. We'll check and see. And it actually attaches to the part, and it basically makes the bottom layer bigger. So, and you cut off the excess later, but it'll let it stick better. If your print surface is really wavy and everything, you might just print on a raft. So what it does is it spends the first time extruding this really heavy material to create a flat surface for you to print on, and then you print on top of that thing. Or you can just do none. This would probably be fine with none. I'm going to use skirt. I think that's the one I want. We'll slice it. So then I've got all these set the way I want them. There are many, many, many more options that we'll talk about later. This one is printing though, and you slice it. And this one doesn't take very long. It says it's going to take 17 minutes to print. It's going to take 3 grams of filament, which I've certainly got 3 grams here. Or if I want to measure it in weight, in length, 1.13 meters. I want to preview it though. All right, so yeah, this is the skirt. See these 3 lines that are out away from everything? That's the skirt. And it's basically, I'm just using that to make sure it's printing in the right spot, make sure it's going to stick, and that it cleans the nozzle out, it purges it. Actually, I may have problems with that. I need to heat this. We'll come back to that. You normally want to go through and run through this little slider. So see how it's hollow on the inside? Let's see if I can get it. That is the infill. So it's not solid in there. And if I went and made it more solid, so where's it at? Infill. So it was at 20 before. And reslice it. Now see it's got more stuff inside there. So you do have to have some amount of infill for most things. If you want to put a top on them anyway, it is possible to bridge all the way across there with no infill at all, but normally you want some amount of infill. 15% might be a good number. We'll do that. There are some times when you can print with no infill at all, though. Notice there's 2 walls, so it's going to print 2 outer walls. That's probably as few as you want. You can print with 1 wall, but it's going to be very flimsy. If it's a structural thing, you probably want 3 walls in there. Let's see how many top and bottom layers it has. So there's 1, 2, 3, 4 bottom layers. So there should be, 4 bottom layers. Top layers, there should be 4 of those if we went all the way to the top. So 1, I wonder if I can go down with arrow keys. Yeah, 2, 3, 4 top layers of solid printed stuff. Those are all options you can change. All right, so I've got my file. I need to save it on here, so we'll get this thing in here. Most of these do run, like I said, on SD cards. So you do need a way to get the file from your computer to the SD card. Fortunately, my computer has an SD card slot. So I don't know, most of them use the regular size SD, but there are a few that I've seen with the micro SD on there. All right, so we're just going to save it here. Save to removable drive. It's going to be called TT. So Kira adds the initials of the printer. So this is Timo Tarantula, and then the file name. We're going to eject that thing. All right, safe to remove it. Then let's see. Let's go over here. So on this one, I don't know if this rotates very well. But there, got a little screen and the SD card in. Can I make it do? Oh yeah, maybe it's readable. Is it upside down though? It is. There we go. All right. So most all of them interface with some little screen like this, where you've got a screen. Some are touch screen. Most of them have a little knob. This one has a little stop button down here. So it says card inserted. That's good. Sometimes they don't catch that the card is inserted right away. You have to do it a couple of times to get the thing to read that there's a card in there. You push the button. You might want to go ahead and prepare this beforehand so you can preheat for PLA. You can heat just the hot end, or just the bed, or both. I'm going to do both because I've got some red filament that's kind of hanging out of here. I got to get it out of there, so we'll have to remove that. So it's showing me. Oh, whoa. It's showing me the hot end set point temperature of 200 degrees Celsius, and where it's currently at. The heated bed is wanting to go to 50, and it's currently at 23. So it's kind of heating both at the same time. Some printers will do one and then the other. Some will do both at the same time. This one's doing both at the same time. This is showing this fan. So this 100% fan, that is this fan. This fan has to be running if your hot end is heated up. Oh, mine's going to make a annoying sound. I have to fix that. All right, well, we'll just have to deal with that for now. This fan is the one that cools the cool side of the hot end. So you only want the very bottom down here hot. This part you actually need to stay cool, otherwise you melt the filament way up here and you can't push more in there. So the filament should only be melted down in the bottom, and you'll see that when you do the SolidWorks thing. On this one is actually, yeah, that may be the layer fans. Yes, this one is layer fans. I don't know why they're on right now, but I guess it just defaults to them coming on. This one, well, can't see that. This one should always be on. As long as this is on, this should be on. It won't turn on when you turn the printer on, but this fan should be on when you're printing all the time. These, wherever they might be, may or may not be on. When you're printing PLA, they'll probably be off for the first 2 layers, or maybe just the first layer. But once you get more layers printed, these, wherever they're at, they're going to be on different spots on your printer. They do need to be on for PLA. And we'll talk more about the individual different materials later, but this is PLA that's in here, or that will be in here. Actually, no, it's not. It's this stuff. So this is a little thing, I don't remember what it's called, Maker Box. And they send, well, they don't send, I buy samples of filament just so I can try different stuff. So we're going to print this one called linen. It says hot end temperature is 200 to 210. I didn't actually even check that on our printer settings. That's one of the things that you can change in the slicer. But it says print like PLA. So I'm going to go with PLA. We can change on our deal here if it's printing too cold. All right, so now we got to get this old stuff out. Oh wow, this one's going to be fun. There it goes. Oh, not going to be fun at all. It's so sometimes when you leave filament in a printer, it like this one's disintegrating as we go. Maybe we can get it to all come out of here. I don't know. We may just have to run that through it, and that might be problems. It's kind of, we'll shove it through there. We'll do that. Hope that works. So we might get a partly red and partly whatever color this is, linen print. Or we may get no print at all. We'll see. All right, so normally these come on a spool. This does not, because it's just a little sample. It's generally not great to print not on a spool because it stands a chance of tangling up a good bit, but I think we'll be okay with this one. Grabbing it. There it goes. All right, so we're just going to feed in some of this and see if it will. You're looking to down here. You want this to purge. Yeah, so it's hot enough to spit that red plastic out. Sort of. Not too fast, though. It couldn't keep up with that. So there is a limit on how fast you can actually extrude filament because it does have to melt right in here. I want to see if I can get most of that red out, though, because it was kind of brittle. If you have filament that's brittle, then it is probably going to be tough to print. And this was pretty brittle. Now, there are some filament that is just brittle to begin with, like the copper fill that has copper built into it. It's super brittle. Some of the wood filaments are kind of brittle. There's filaments that they have a base plastic like PLA, but then they have sawdust in them, and they print wood. It actually smells like a campfire when you're printing with them. I'll point this out. All of those materials that are really cool and they have stuff in them, if you have this regular old brass nozzle that your printer came with, you won't be able to print for very long. Maybe, I don't know, not even that whole roll of filament because they're very abrasive, particularly the metal ones, the ones that have metal in there, or carbon fiber or stuff like that. They're very abrasive to that nozzle, and it will wear it out to where it'll still print, but it won't be 0.4 millimeters anymore. It'll be oval shaped and bigger or whatever. So if you do want to print with any of those more exotic filaments, the blends, then be aware that you'll probably either want to put a hardened nozzle in or just have a bunch of the brass nozzles to replace with. They're super cheap. The brass nozzles are like $1. So it's not a big deal to change them out. We're almost out of the red. Starting to go too fast though. I don't know if y'all can hear it. I can hear it. There's a clicking, not that clicking sound, but a clicking sound coming from the extruder. When that's happening, that means that your whatever setup you have on your feeder is skipping. And so you're either printing too soft, you've got a clog, printing too cold, so you need to bump up the temperature on your hot end. You're printing too fast, so it's trying to put more filament out than it can heat up in a reasonable amount of time. You're too close to the bed, so there's no room for it to filament out. Or you're printing too cold, so you need to heat up the nozzle some more. Like that sound. It's starting to turn pink, so I think we're almost there. Yes. Be careful. That is very, very hot. And the bed is hot, but it's not crazy hot. Again, I'm touching it, so it's probably going to not stick very well. All right. Still, since this, I went from a red to a whitish color. For whatever reason, it takes a long time to get all of the remnants of the red out of the nozzle. Like it gets buried in there. So it looks like we're close enough now. I don't actually care what color this ends up, so it'll be fine. All right. So now we're heated up to 250, or 200 on the nozzle, 50 on the bed. Card is inserted. Oh, is there a way to focus that better? Here we go. Now, we want to print from SD. So if you had your USB cable plugged into the printer, you could print straight from there, but I don't. So I'm going to do that. I've got all kinds of stuff on here. I'm looking for this one, the Tarantula XYZ Calibration Cube. All right. And then, so the settings actually called for the bed to be at 60. It was at 50. So it's telling me that it's going to heat up some more on the bed because it wasn't as hot as I told it to be apparently in Cura. And so it's going to spend a little bit of time heating up. I do want to check one thing. Oh, wow. All right. So this printer, I have not, and I guess this will be one of the first things that we add because I like it. There is a setting that you can enable in your firmware to let you control the height of the bed in live printing, so you can actually move the bed up and down as it's printing. It's called baby stepping. Most of the time is what it's called in the firmware. I don't have it turned on here unless it's going to let me do that after it starts printing. We'll try again. If that's not the case, a lot of times what you have to do, we didn't level the bed or anything. We just started it up printing. You would definitely want to go the first time and at least move the print head to each of the four corners. Have it heated up. Heat the bed if you have a heated bed. You let it get to printing temperatures and use these knobs down here to get the bed as level as you could with the four corners. Basically, you want it like 0.1 millimeters or so off of the surface, just so you can see a tiny gap. I assume I did that the last time I used this printer. I don't know. We'll find out if it ever heats up. You don't have to have the bed on at all, and you don't even really have to have it at 60 if it takes a long time to heat up. But it's still going. It's at 58. Once it gets to satisfied that it's at the right set points here, it'll take over and it should go in and home. We could have tried that beforehand. So it doesn't currently know, I can move this all around. So it doesn't really know where it's at. So it needs to figure that out. So there's little limit switches over here, and there's one there. There's one at the back. So it'll go and find all those limit switches. And then it'll know basically where this front corner is. All right, so everything's up to temperature. There it goes. All right, so here it's finding home. Now it's finding that home. Now it'll find the Z. Now what we're looking at is we don't want it to, it looks like it's going to be too high. So the only way I can, oh wait, I want to, Yeah, I can't tune it there. Oh, I can. All right, so baby step Z. So it needs to go down though. So our first layers are too high, but I can lower it down to something more reasonable. So we'll have a bad couple of layers. That's also another reason. Let's see if I can get it to kind of look in there. I don't know. I'm trying to see it. It's very junky in there because those first few layers are bad. It may have trouble focusing with it moving back and forth. So, but the more of those little skirt layers that you make, the more time you have to get it correct by adjusting like the height of everything as it's printing. We didn't have a whole lot of time, and I didn't even know I could do it. So now it'll print for a while. On the baby step, what this does is it lets me basically set, I move the z-axis down negative by 0.626 millimeters. So I had to drop it down a little over half a millimeter to get it closer to the bed because I could tell that it was too high. It was printing almost in the air. What you're looking for is, so if your nozzle, your nozzle comes out something like this, they're usually not quite that steep, but if it comes out like that, then your filament is melted and it's coming out of a little stream here. You know, this is the 0.4 millimeters. This nozzle, oops, that way. Most years that's 0.4 millimeters. And so what you want is you want this nozzle to be squirting out filament where it's squished a little bit, kind of like that. You don't, so that's more or less what I'm looking for. I don't want something where it's just kind of laying it on the bed like that because it won't stick. And I don't, so that's not good. And I don't want where it's so close that it's, you know, it's almost transparent even, because if it can extrude anything, it extrudes it almost transparent. Usually when you're that close, that's when you'll hear the clicking sound and it won't be able to extrude anything. Our little printer, I think it actually might stick this time. It might be okay. It's kind of look like it's, yeah, it's gonna stick well enough. We'll get it off of there and see. The bottom's going to be a little messed up, but it'll be okay. And on your little panel here, again, it told me in Cura like 17 minutes or something. If I go back to the main info screen, then it tells me I've been going 6 minutes, gives me a little progress bar. Those are kind of accurate. I wouldn't like time anything based on them, but they give you a rough idea of generally how long is it going to take. Is it going to take, you know, 30-ish minutes or 3 hours or something like that? It'll give you an idea in Cura before you even set the thing. So, you know, it says 18 minutes is the, oh, because I raised the infill a little bit. So it's a 4 grams, a little bit more filament. Since I don't have a spool holder, you want to make sure every now and then that this isn't getting tangled up, because it can knot up and not be able to pull filament through. And then you can let it go. And the first few times I wouldn't like leave it, and I wouldn't do really long prints on the first few attempts. I would just do some relatively short, maybe like 20-minute prints like this, and sit there with it, make sure that nothing is obviously wrong or whatever. I generally don't leave them completely alone for very long at all, just because you don't know what's going to happen. Now, commercial printers, you leave those, you put a file in there and you just leave them. These, I still kind of, you know, you just want to make sure that there's not a fire problem with them, or at least a melting problem with them. So maybe we'll finish that print up. I don't know. Are there any questions about stuff right now? Assignments or anything? Yeah. Okay. The temperature control or Oh, okay. You're talking, yes. So sometimes the TL smoother is what you're talking about. And those things are they're relatively cheap. I've put them on. I don't have them on this printer. I've put them on other printers, and they are little plug-in devices that go in the brain of the computer, and they will help, but they don't necessarily cure all of that stuff. But they can help. They don't hurt, and they just plug in, and they're like $18. So I don't think that'd be the very first thing that like, oh, I got to add this. But if I've done all the others, then that might be the thing I'd add. Yeah, if they'll let you. That's kind of more